Newton's first law states that a still object will stay motionless and a moving object will stay in motion unless an unbalanced force is exerted on the object.
For example, if a unicorn is flying through the sky at a constant speed, it will maintain that speed unless it encounters an unbalanced force, like running into a cloud.
A free body diagram is a visual representation of all the forces acting upon an object. The forces acting upon the unicorn are air resistance, gravity, lift force, and applied force. Opposite forces cancel each other out. And because air resistance and applied force and gravity and lift force are equal, the net force equals 0. This results in a constant speed.
Suppose that the unicorn's applied force is greater than the air resistance. This would result in a net force not equal to 0, causing the unicorn to accelerate.
Newton's second law is an equation that states that the net force equals an object's mass times its acceleration, F equals ma. For example, if an object's mass is 5 kilograms and its acceleration is 3 meters per second squared, then the net force acting upon the object is 15 newtons.
When the mass of an object increases, its net force increases as well. Similarly, when the acceleration increases, the net force increases.
Acceleration equals change in velocity divided by the change in time. Therefore, as the time goes up, the net force goes down. On the other hand, as the velocity goes up, the net force also goes up.
Newton's third law states that for every force that is exerted, a second force, equal to the first, is exerted but in the opposite direction.
For example, if a person pushes against the wall with 10 newtons, the wall exerts a force of 10 newtons back on the person, resulting in a net force of 0, which is why the wall doesn't move.
The masses of two objects do not affect this law. For example, if a big pig pushes against a small pig with 8 newtons to the left, the small pig will exert a force of 8 newtons to the right, despite the difference in their masses. This also results in a net force of 0.